So we are going to talk about surfaces. Even though we've already talked about surface analysis, 3D visualization, and surface analysis, the particular one we touched on was view shed analysis. But I think I should have talked more, even describe what a surface is before we started a view shed analysis. It happens sometimes. So we all make mistakes sometimes. I think it should have been the other way around. So, but don't worry about it. I'll still take my time and then touch on what the surface is, even though the previous lecture touched on what a surface is. So, what are surfaces? Surfaces are really like a certain area with several values. If you have a certain region, okay, in which you have values at every point within that region, then you are dealing with a surface. So you can have, say, a temperature surface. You can have an elevation surface. So on a temperature surface, for example, then everywhere you go, there's a value for temperature. Okay. On an elevation surface, we call it a digital elevation model, what we talked about the last time. The prerequisite for doing a view shed analysis. Okay. So surfaces really are a phenomenon that has values across their extent. Okay. So when you look at a particular surface, you're actually looking at all values everywhere. There are no holes, there are no spaces. Are you okay? All right, so let me share this one with you and then we'll just go. So surfaces represent phenomena that have values at every point across their extent. Okay, the values are the infinite number of points across the surface. So here we're talking about an infinite number. Let me take an elevation, for example. When you look at the whole idea of height, anywhere you don't have a height, it means you are going down. Okay, if the height difference between where you are standing and then where you are, okay, it's like so much, it means you drop down. Are you all right? So that you probably have a continuum. Are you okay? All right. So continuous data, that's what we actually refer to. We have discrete data in GIS, and we have continuous data. And for surfaces, they are continuous. You cannot say I've missed some value here. You got to have a value at every point across the particular surface of interest. Okay. All right. So you can actually measure values. Are you okay? You can measure such as height. You can use total station instruments to measure in the case of an elevation surface. So you can talk about temperature values too. So in that case, then you have an instrument that should measure it. But how do you then have values at every point in terms of representation? You have to do what we call the interpolation. Is that okay? All right. So between the values that you measure for surveyors measure with the total station, you realize that in between one point and the other, you don't know what the value is. So you have to find it. So you have to make use of something like an interpolation. All right. You can have even surfaces showing concentration of criminal activity. But of course, as engineers, we know this is more social science. Surfaces can be represented at using contour lines. Are you okay? We can use points, arrays of points, or a grid points. Are you okay? And then you can also use facets like triangular faces, triangles. Are you okay? And then you shade it according to the value at the intersection. Are you okay? The vertices of the triangle. You can also use a raster. Okay, so the raster model, if you think about the raster model, then the raster model makes use of cells, which have been arranged in columns and rows. Okay, so these are three different ways: lines, points, tins, triangular, irregular networks, and then rasters. Okay, so you can use any of these to represent a surface. However, the most It says that most surface analysis in GIS is done using raster. So you have to generate, a raster. Normally you will have to do a vector to raster conversion. Is okay. So the software allows you to do that. Okay. There are a whole lot of analysis tools that are available in GIS software, most GIS software that claim to do this kind of analysis, okay, spatial analysis. And so we need to look for the tool for the conversion and then really obtain a raster of a certain resolution. Is that okay? All right. It comes with its own accuracy issues. So contours are sets of lines of equal value across the surface. Okay. So we need to understand what contours are. That's the basic in terms of surfaces. It's all right. Yep. It may not effectively represent, the particular surface of interest, but then it does make an attempt because, for example, you look at a set of contour lines and then interpret and tell the kind of surface that you are actually on if you have that skill. All right. So contour lines, I don't know if you can see my screen. When you see a contour line like that, can you see my whiteboard? Then we can.
No, please.
You can see. Okay, I'm just have to share it. I not see my whiteboard. Do you see me writing something?
Now.
Do you see me? You can see. Okay, great.
Yes, please.
So in a contour, you can have values. So what it means that this line, if you actually work on this line, then you will never drop down or go up. Okay, because the height along that line is the same throughout along the line. Okay, so how does that represent the surface? We can, by just looking at contour, we can have an idea of the shape of the terrain. Okay, we can have an idea of the shape of the terrain. So someone can look at this and say, okay, there is some kind of hill going on here. Are you all right? So we're going up the hill, going down the hill. Are you with me? Okay, so we are representing a surface using lines. So this is how it is done. All right, you need to understand this. You can use points to represent a surface. In that case, I was talking about spot height. So spot height, like height at random points, but normally you can grade it. Normally, when you pick spot heights, you grade the area of interest. So the points can be regularly or irregularly distributed, as I said, across the surface. But usually you go for regular grade. It helps. It's okay. Okay, so they are usually represented as input, interpolation, Kriging, triangulation tools, blah, blah, blah. Once you have your spot heights or points, yeah, that represent height, that have height, we can do an interpolation. And then the interpolation then yields values for points where we have no values for. Is that okay? So you need to understand that. So the points don't effectively represent the surface because in between the 2 points, the values there we never know what they are. Okay, we can start with points and then generate. Are you okay? It's very important to also know that we can use photogrammetry to generate a raster. Are you okay? So before we even get there, which is the last one we're going to talk about, I want you to be aware that we can use photogrammetry to generate the rasters. Are you okay? All right. So we've talked about the TIN, the triangular irregular network, the access of triangular facets defined by nodes and edges that cover a surface. All right. A very important, module for, the cartoon 3D modeling when you want to do 3D modeling. All right. So lines where the shape of the surface are probably changes, such as ridge lines, streams, blah, blah, are incorporated into the thing. We can keep on talking about it, but at the end of the day, just lines and then, the triangular facets that are creating an impression of, the elevated values. Okay, but like I said, it doesn't have to be elevation. It can be temperature. It can be any value that we are interested in. Rasters, like we said, most analysis are done, spatial analysis are done using rasters. Let me give you an example. Example is what people are using their phones to do. You see people buy their expensive phones and then they install IG, Instagram on it, and then they take a picture and then the picture, they can do makeup. All those things are actually spatial analysis. It's actually image analysis, changing the image processing. Are you with me? And it's like one of the most effective ways if you want to do an analysis, spatial analysis, you make use of the raster as an input, and it really helps. Okay, there's a whole lot that can be done. Hydrological analysis can be done using rasters. Okay, so rasters are rectangular arrays. I think we know them already, each of which stores a value for the part of the surface it covers, etc. You need to understand the word resolution when we talk about raster. It's the cell size. Okay, so if I give you a raster right now, you need to measure and find out, or you need to be able to read as part of the metadata what the resolution is. It tells you the accuracy of the particular raster. The simplicity of the raster structure makes calculations on raster faster. So as we said, okay, so this is the real reason why we want to do spatial analysis and filtering in raster, because it's simple. Okay, you have rows and columns looking like a matrix. And once you have a matrix, then you can define rows in every cell by the row and column number. Okay, so there we go. Rasters are used to store imagery, schema, etc. Anytime you have a picture, anytime you scan and you have an image, so photo, image, picture, all these are raster. They make use of the raster concept. Are you okay? All right. So you can actually create a surface. You may not initially have a surface, but you can create a surface, because we define a surface as a phenomenon with values across at every point across its extent. So we normally don't start with a surface, but we can create one. It's assumed in your raster model that every single point has a value. Are you okay? And depending on the resolution, it can be very useful for you. If the resolution is not good, then there's a lot of generalization that has happened and the raster cannot be relied on. So like I said, interpolation will come in handy when we need to create a surface. Are you okay? All right. So we can derive surfaces of even distance. You look at it that way. This is the interesting thing. We can derive surface of distance from a feature of features, or deriving a surface from another surface. So there's a whole lot that can be done. So I won't talk about all of it, but I will talk about what you need to know for what you need to do, what you need for this course, for the scope of this course. So interpolation tools are, if I only want to do interpolation, there are two methods. You have the inverse distance weighted and the nearest neighbor methods. Is that okay? But let's read about the interpolation a bit. Let's talk about it. Interpolation tools create continuous surface from discrete samples with measured values such as elevation, chemical concentration, and of course, that is the whole idea. When you look at this picture here, we have generated the green color behind it, background color, is the one that is the actual surface. Meanwhile, the points are not the surface, but then the screen surface has been created and generated from the points. Is that okay? Such that now we have different values across the extent. Okay. So now we made use of IDW. So as the IDW is seen, there is an inverse distance weighted method for interpolation. Here we made use of what we call a spline. So the spline is some kind of curve. In other words, a mathematical module. It's like a curve fitting module. Okay, most of the time when you're actually modeling, that's what you do. You try to, formulate, okay, find out whether there's a relationship. So the spline does the same thing. Then we have the nearest neighbors, which also interpolates, taking into consideration the nearest neighbor. Okay, so that is basically it for interpolation. It helps us. So you can imagine that there's the program goes picking the values that you see, 184, 272, and then it determines, it will have to grid. Okay, the surface being created, has to be like, you first have to create it without any values. Then you do the interpolation, then you assign the value. We can have what we call kernel density estimation. That is also a way to determine. We'll talk about density tools very soon, but obviously there are, formulas and processes that allow us to generate new surfaces. So the simplest interpolation tools are the inverse. I've talked about that already. The inverse distance weighted, and then the natural neighbor interpolation. Is that okay? All right. So at the end of the day, we make use of the points. You never interpolate if you don't have some known points. You have to get some known points. At the end of the day, we obtain a surface looking at what you are looking at right now on your screen. So on this surface, the actual points are the dots, and then the surface, you can actually visualize it. I believe you can feel that this is like some kind of mountainous area. The whitish areas have higher values, so it's like you are going up the hill, and then the lower values are here. In fact, you don't need to generate this to have a surface. All you need is the raster. Are you okay? So when we generate a surface, we can choose to render the surface. So this surface is rendered. Are you okay? In other words, it's been visualized as if we believe that someone can work on this. Okay, so that impression is quite psychological. Are you okay? We have used light and shading to create an effect of a 3D. Are you okay? All right, so that is IDW for you. Natural neighbor interpolation is like IDW interpolation, except that, so IDW makes use of the distance between the point to be determined and how close the points are to the point. The farther the point is, the lesser its contribution to the calculation of the new point. So that is inverse distance weighted interpolation. Are you okay? So it makes use of the Delaunay triangulation, which we can talk about it later on. Natural neighbors interpolation reliably works with much larger data sets than the other interpolation methods. Is that okay? So yeah, these are all methods that work. We talked about the spline, and they make use of the best fits surfaces. Is that okay? But you can look at it in terms like you look at a line of best fit. You plot a few lines, a few points, and then you try to fit a line such that you can have a minimum. Are you okay? Error. Okay. So we can have the spline interpolation. Of course, strain surfaces can also be used, and they are good for identifying core scale patterns. The whole idea is to find a pattern within data. That's also the okay. So we can also look at density. So by just creating a density surface, that is this, you have a surface. All right. So density tools produce a surface that represents how much or how many of something there are per unit area. Okay, so we can also use the density tools. Like I said, the kernel density estimator is one of them. All right, so example is being given here. Representation of the distribution of a wildlife population. Okay, and they all help. But once you see a surface, it tells you a lot, especially when you visualize it in 3 dimensions. There's a lot that you can do. Here we have a set of points, and then we've created a surface up here. All right, so you can see the areas where there are less points, you have a lighter color, and then where we have more points, we're using a darker and deeper color. And on the right hand side, we have lines. So you can also create the density of lines. Okay, a density surface based on lines. Okay, so we don't only do it for the points, we can do it for lines as well. All right, and I'm skipping some of these things, so please, when you get the material, I know which one to skip. Are you good? All right, so yeah, I'm skipping this one. Yeah, not talking about that. All right, there's a whole lot that we can talk about. I'm picking on and choosing the ones that I want to look at for now. So in analyzing surfaces, we can actually we can make use of what we call the terrain analysis. Okay, so in terrain analysis, we can create a slope surface. So we are still talking about surfaces. All right, so the slope surface will now tell you, the rate of change from cell to cell, the values, how are they changing? Then you get a slope. Example is what we are looking at here. So in this raster on the left hand side, on the right hand side, we have visualized it, the surface. And so higher values are looking like mountain, top of mountains, lower values are looking like valleys. Are you okay? So the slope surface just does that. The aspect tells you the direction of the slope. So you can create an aspect surface. So this is an aspect surface. Whenever you see an aspect surface, this one is an aspect surface. The reason you know it's an aspect surface is that the values normally range between 0 and 360. More or less like as if the surface is actually moving in a particular point in a particular, bearing. Are you okay? So bearings start from 0 to 360. All right. So when you look in here, you can see that the values with the cyan color, when you match it, then we are getting these areas. So they are all pointing south. So what does it tell you? It tells you that your south is somewhere here. Trying to get a test. So the south is somewhere here. Okay, because when you look at it, all the cyan values seem to be pointing to the left-hand side. Okay, so there we go. We need to be able to appreciate some of these things, about surfaces, especially the aspect, slope. Okay, they are very good for engineering, isn't it? If you really want to site, a facility or something like that, and we didn't want people to see a particular area, if ever that came into the planning of, the actual project, the part of the planning, then of course you need something like this to help you. You can have a hill shade. A hill shade assumes that there's light coming from one angle, okay, and then of course there are shadows created, and therefore you end up having what, the impression that there's a solid. Okay, there's a solid. So in this diagram, for example, you can, on the left hand side, before we visualize it on the right hand side, on the left hand side, you can see that it looks almost like a solid, like something you can hold, something you can walk on. Are you okay? So we call that a hill shade. A hill shade. Okay, a hill shade. All right, and more. So there are more tools available to you. Yes, line of sight analysis is coming up again over here, because I picked this material from GIS anyway. So yep, it's very important for us that there's a whole lot that you can do in this. Okay, you can also have volume tools to calculate volume, but these are quite practical. Cut and fill, we all know that as engineers, we always need to do those things. They are possible in GIS. Okay, so now let's talk about classification. So when you take every raster data, it's a classification of a sort. Immediately you take it, a picture of someone, it's not the person you are looking at exactly, because the picture you have in your hand is actually squares, and the value of every square is actually telling you the value where you are in that box, in that cell. Okay, so we already have classified. Once you have a raster data, you already have done some classification. That's what I want you to know. And that is the reason why we go straight away and talk about reclassification, because it means you've already classified, you're doing it again. So we are reclassifying. Like, why is this important? In multi-criteria analysis, Israel, if you want to combine several factors, so I want to find out, all areas which are most, which are farther away from a particular dump site for my project, then you need to create a surface in which you have classified it in such a way that only values, areas which are far away have, certain values, so that you can now recombine that with another factor. So they are different. We call that multi-criteria, analysis. And when to be able to do that, you need to do a lot of reclassification, and then combine the values. I mean, unless you actually do a practical, you'll be imagining things. Okay, so what we do in one of the things that we do in GIS is to take an image and reclassify it. Okay, so this image on the left hand side, black and white, is being reclassified, or originally it is actually a panchromatic black and white imagery varying from pure white to pure black. Okay, so the whitish areas have, say, the smallest values, and then the black areas have the highest values. Okay, so now as we reclassify, we can see that we are now using fewer values. What are the values? The green, the light green, in a few shades of green, and then blue and a few shades of blue as well. So we reduce the classification like 20 or something like that. Whilst over here, we have just all range of values on the left hand side. So we have reclassified. Then we can even classify further and have just two values. And these values could represent whether there is water or there is not, whether there is vegetation or is bare land, things like that. Are you okay? Or you can just, group it in such a way that it identifies whether an area is, a certain value. It depends. So the criteria, you have to set it. So there are values you can set for the classification to be done for you. Okay. So when you do any classification, you have to specify. In the mathematical, you have to say all values greater than 1, give it a value of 10. All values less than 1, give the value of that. Then you end up classifying to just 2 classes. Israel, I hope you follow it. I want you to grasp this one because of your interest. Okay, great. So down here, you can see we are actually reclassifying a slope surface, an aspect raster, an aspect surface, an aspect raster. All right, so here the 2 classes are south and southwest. Okay, we want to just find out areas which are facing south and southwest, because we want to do something about. So you see the result that we get. Okay, we are now having we are now grouping values. So classification, I think if we still remember, classification is where you just do 1 to 10, and then you do 10 to 20. This was done in like JHS or I don't know, O level, or depending on where you are coming from. Okay, when we start doing this, we are classifying. Meanwhile, the original data is not like that. Okay, it's a whole lot of values, okay, which are together without any classification at all. All right, so in this case, we are classifying with intervals of, say, 10, if you like. Okay, so that is the same thing that happens with the raster, simply because we have what? Values. The raster always contains of values. Every cell has values. So we can now play around with it. We can make use of, tools within the software, or we can actually use what we call like a raster calculator. Is that okay? So I think you see it again as we go. So south and west, okay. So 1 is light, other aspect values have 0, dark, so that we can now plan the event. So you can imagine what this can mean to us. All right. So that is the aspect raster for you. Okay, now you can create other surfaces based on proximity. Are you okay? How close or far things are from you, and then so the software is able to do that. You can just say that, okay, if I'm moving from here to here, show me the surface of, the cost distance. How much does it cost me moving from here to here? Are you okay? How much does it cost me? So you have a cost distance. Are you okay? You have cost distance. And you can have cost allocation, cost, but all these are just surfaces that we can actually create. All right, so we are not looking at them like in detail. We are just picking and choosing, okay, depending on what we want to do. All right, overlay tool. So we talked about map algebra. Map algebra is your ability to just take one raster and add another one to it. So remember that we can take, can you imagine if I take a picture of myself, took a picture of yourself, and then I added the color values? What would you have? Try it and see what happens. I haven't seen anybody do it. You can try it out. But that is what overlay in rasters mean. It means, but the assumption, in fact, the very assumption you should make at the beginning, you should ensure that the cells are of the same size before you can add 2 rasters. They have to be of the same resolution. So you may have to resample. Ayaki, you may have to resample. All right. So yep, we can do a whole lot. We can do a whole lot. No, no. Oh my God. Like I was saying, there's a whole lot that we can do. So here you can see we are actually doing addition and all that. It's possible. Okay. We can actually do the cookie cutter thing that we talked about, data extraction. When we do overlay, remember, we can do union overlay, intersect overlay. All those things can be done in raster as well. We can cut and extract parts of the data. All right. So all these things are possible. You can do hydrology. In fact, I can't talk about all of them. You can create a basin. It depends on what you want to do. All right. And then it is possible that you can then do it, get it done. All right, so there you go. Especially for hydrology, rasters are the way to go. The raster surface is the way to go. All right. So yep. Okay, guys. So basically, this is you can ask questions. I mean, if you like. Otherwise, I think we'll end it here. And then, I want you to get ready for practical. Yes.
Overlay tools.
Yes. Yes. Yeah, overlay tools. Yeah. So the raster overlay tools combine two or more rasters. Yes.
Yeah. So take a picture. I want to know whether element. An example.
Mm.
If it is human being with say, let's say the person is that complexion,
Yes.
or I'm feeling if it is of the same element, we will not see the effectiveness of the tool.
Yes, yes, that's right.
In that, assuming even we are using colors and they are green, if it is green, you wouldn't see of the same of different colors. You could see it effective.
Yes. Yes, so you are right. You are right in saying that you need to compare the same objects of the same make or shape. Yes, then it will be relevant. But I think that so the human being one will not work very well. But I'm just saying that you could try it and see it to be interesting if you could just. But the truth is that in GIS, the photos that are used, the images that are used are not photos of human beings. They're actually photos on the ground. They are images on the ground. When you take an image, even on the ground, a photograph on the ground, an image on the ground, initially they don't have any value. What the values they have are just I don't know, like color values. Are you okay? So they don't make sense. It's only the digital elevation model that has values that relate to what's elevation. Okay. Otherwise, the pictures that we take, the values in there are just color values. And I hope you know that colors have numbers associated with them. Are you aware? Colors have a value of 0 to 256. So when you take a color like green, even okay, let's take black and white. So black and white, also known as panchromatic. I'm talking about overlay. So if you are overlaying, we'll be combining 0. If the value there is 0, then it's 0 plus. Are you with me? And then it has to be the same location. You should know what you are doing with your combination. So if you're adding two values, then you know why I'm adding this raster to this one. Normally, you combine them in suitability analysis, which is where your interest is. So you need to get ready to take the same area and then combine several values based on reclassification. This is how you do it. But then on a normal day, if you want to do some kind of analysis using GIS, you may want to be looking at, say, your face. You take a picture of your face today, and then maybe 3 years on, you take a picture of your face again, then you compare the values. But then you should have sat at the same location, the same orientation, and then compare. Then you see that maybe you are getting darker or lighter. Are you with me? That would be an interesting one, isn't it? Engineers are interested on stuff's happening around you, physical environment. So in that case, that was something I said, by the way, but I think it is worth trying it if anybody's interested. Medical science may make use of that, okay, but that's not engineering. But because our course is more on engineering, something that's even interesting, we just say it in passing. Anyway, we need to look at what can we combine. Okay, what can we combine? We will have to start with the surfaces. The combination will be done almost automatically. Okay, for example, if I give you a set of points with values, will you be able to create a raster surface from that? Because once you get a raster surface from that, we can do a reclassification. Okay, and once you can do a reclassification, we can do a combination. Okay, so I can say that in terms of suitability, we can have a scale of 1 to 10 in terms of suitability for, say, all places that are a certain distance from the road. So this is engineering, which of course, like I said, talking about it like this in the narrative is not going to be easy. It's going to be a bit easier if it's practical. Okay, so but then the theory is that we can combine different surfaces, usually because we want to find out the cumulative effect. Okay, the cumulative effect of doing that. So several factors can be combined to find out whether the area is susceptible to flooding and all these things. So if you want to look at areas that are susceptible to flooding, for example, we all know that you need to look at the slopes, isn't it? So you need the slope surface. Are you with me? So we take this, but just that's not the only thing. You have to look at areas that are built up. Built up areas, normally the water doesn't seep down. Okay, because areas are paved, and that's why you have places like Kaneshi always flooding, because we tard every place. Yeah, and that causes flooding as well. So we need to look at that factor of paving areas that have been paved, and then look at the slopes as another factor. But there is more. Remember, you look at the rates at which the water is actually falling and factor also that one into it. Are you okay? Places in Ashanti region probably don't get flooded as here, etc. We can also look at areas where there's a river, already there's a river. So you can imagine that you probably have, the area getting flooded. Yeah, it will yield to flooding as compared to areas where, we don't have, any river at all. Okay. So yes, the overlay makes use of algebra. What is algebra? Algebra is where you take a variable, isn't it? And you can multiply by a constant. You can subtract and all that. So map algebra, in map algebra, the variable is the map as an input. So, okay, but that particular map as an input, then it's a surface which has been can we say costed? It was the past tense of cost. That we can cost. Okay, if we can cost a surface, then we can now add up, probably reclassify. Very important to reclassify, so that we will have the same scale, and say that on a scale of 1 to 10 for the paved areas, this is the best place to put it. Meanwhile, when you look at in terms of slopes, this is the best area. Then we combine all of them, then you find, okay, then this is the actual, then we get a particular area which is delineated and can be used. Okay, so depending on the software, like I said, this material is based on GIS, so they'll be using certain things, functions that they already created, but the concept is the same. Okay, that we can overlay. Okay, we can overlay. All right. Okay, so any further questions on this one? I think today this is all we are talking about, and then we say goodbye. So if you have any question, otherwise I can prepare you for our next meeting. I tried a practical with a certain class, and in fact it was interesting. So I'm going to share some of the experiences with you. All right.